show that a simple dynamic system moves in accordance with the Lagrange's equation of motion for d or dt of partial derivative dl upon dq minus del L upon del q is equal to 0. Solution: let q, q1, q2 and so on qn be the independent generalized coordinates corresponding to the old coordinates Ri, so that Ri is equal to Ri bracket starts q1, q2, so on qn and t. So Vi is equal to dRi upon dt, or Vi is equal to sigma p del Ri del qp dot plus del Ri over del dt. Further, the infinitesimal displacement of delta Ri can be further connected with the delta q rho as delta Ri is equal to sigma rho delta Ri upon delta del q rho delta q rho plus delta del Ri over del dt into delta dt. But the last term is 0 since it is a virtual displacement. Only coordinate of displacement is considered and not that of the time. So delta Ri is equal to sigma rho del Ri upon del q rho delta q rho. Virtual move done by the applied force is equal to sigma I Fi delta Ri, which is equal to sigma I Fi bracket start sigma rho delta Ri upon delta q rho delta q rho bracket close, which is equal to sigma I rho sigma Fi delta del Ri upon del q rho delta into delta q rho, which is equal to sigma rho bracket starts sigma I Fi into del Ri upon del q rho bracket close delta q rho, which is equal to sigma rho q rho into delta q rho, where q rho is equal to sigma Fi del Ri upon del q rho are the component of the generalized force. Now sigma pi dot delta Ri is equal to sigma I mi Ri double dot delta Ri, which is equal to sigma I rho mi Ri double dot del Ri upon del q rho delta q rho, which is equal to sigma I rho square bracket starts d over dt of bracket starts mi Ri dot into del Ri upon del q rho bracket close minus mi Ri d over dt of bracket starts del Ri over del q rho bracket close square bracket close delta q rho, which is equal to sigma I rho square bracket starts d over dt of bracket starts mi Ri del Ri upon del q rho square bracket close minus mi Ri dot d over dq rho d over dt of Ri square bracket close delta q rho. Which is equal to sigma I rho square bracket start d over dt of bracket starts mi Vi del Vi upon del q rho dot bracket close mi Vi del Vi upon del q rho square bracket close del q rho, where because del Vi upon del q rho dot is equal to del Ri upon del q rho. So we have sigma rho square bracket start du over dt of curly bracket start du over dq rho bracket starts sigma 1 upon half mv I square bracket close square curly bracket close del over del q rho bracket starts sigma I 1 upon half mi vi square bracket close curly bracket square bracket close delta q rho, which is equal to sigma d square bracket start d over dt of bracket start d del t over del q rho dot bracket close del t over del q rho square bracket close delta q rho. By D. Lambert's principle, we have sigma fi delta ri minus sigma I pi delta ri is equal to 0, or sigma rho q rho delta q rho minus sigma rho square bracket start d over dt of del t over del q rho dot bracket close del t over del q rho square bracket close del q j is equal to 0. So or sigma rho square bracket start d over dt of bracket start del t over del q rho square curly small bracket close minus del t over del q rho minus q rho square bracket close delta q rho is equal to 0, which is equation 5. Now since q are generalized coordinates and are mutually independent, so therefore the virtual displacement of independent of the hence show only if d or dt of partial derivative of t with respect to delta q rho minus del t over del q rho minus q rho is equal to 0, v 0 1 2 3 so on. D over dt of partial derivative d over partial derivative t with respect to q rho dot minus del t over del q rho is equal to q rho rho is equal to 1 2 and so on, which is equation 6 of the system, the commutative, that therefore the forces or the derivable from the potential energy V as q rho is equal to del V over del q rho. Therefore equation 6 become d over dt of del t over q rho minus del t over del q rho is equal to minus del V over del q rho, where rho is equal to 1 to 1 so on. So or d over dt of bracket starts del t over del q rho dot bracket close minus del t over del q rho plus dv over del q rho is equal to 0, rho is equal to 1 to 1 so on, or d over dt of bracket starts and d over dt over del q rho dot bracket close del over del q rho t minus v is equal to 0, rho is 1 to n. Also v is not a function of generalized velocity in q rho dot so that dv over dq rho dot is 0. Therefore the Lagrange's equation for a simple dynamic system is written as d over dt of partial derivative t with respect to q rho dot minus dv over del v over del q rho dot bracket close minus del over del q rho t minus v is equal to 0, rho is 1 to n. So d over dt of square brackets are del t minus v in del q rho square bracket close minus del q rho t minus v is equal to 0, rho varying from 1 to n. So d over dt of square bracket start l over q rho del L or Q rho del L upon Q rho is equal to 0 rho when from 1 to n, where L is equal to T minus V is called the Lagrangian system.